In this video, we will learn about relative density. In order to have a comparative idea about the heaviness or lightness of objects or materials, we define a new term called relative density. The relative density of a given substance is defined as the ratio of density of the substance to the density of pure water at 4 degrees Celsius. Mathematically, we can write relative density of a substance is equal to density of the substance D divided by density of water at 4 degrees Celsius. We know that density is equal to mass per unit volume. Hence, if we take equal volume of given substance as well as water, then the relative density of substance will be equal to mass of the substance divided by volume and mass of the water at 4 degrees Celsius divided by same volume. And since both the volumes are same, we can cancel it out and relative density of substance will be equal to mass of given volume of substance divided by mass of equal volume of water at 4 degrees Celsius. Thus, relative density of a substance may also be defined as the ratio of mass of a given volume of substance to the mass of equal volume of water at 4 degrees Celsius. Here we have relative densities of some substances. Gold is 19.3, aluminium 2.7, mercury 13.6, glycerine 1.3, lead 11.3, ice 0.92, silver 10.5, kerosene 0.8, copper 8.9, cork 0.2, iron 7.8, seawater 1.03. Now let's understand units of relative density. Since relative density is a ratio of two densities, it is a unitless quantity. Thus, relative density is a pure number and has no units. For example, density of copper is 8900 kg per meter cube and density of water at 4 degrees Celsius is 1000 kg per meter cube. So the relative density of copper is equal to 8900 kg per meter cube divided by 1000 kg per meter cube. So we get an answer of 8.9 because these are the same units, so they will cancel out each other. Moving ahead, let's understand the relation between relative density and density of a substance. Since relative density is defined as Rd is equal to density of substance D divided by density of water at 4 degrees Celsius dW. The density of substance will be equal to relative density of the substance into density of water at 4 degrees Celsius, that is density of the substance D is equal to Rd into dW. Since the density of water at 4 degrees Celsius is 1000 kg per meter cube or 1 gram per centimeter cube, we can write the density of the substance is equal to Rd into 1000 kg per meter cube or Rd gram per centimeter cube. Thus, relative density of a substance is numerically equal to the density expressed in gram per centimeter cube. Next, let us understand about variation in density of an object due to temperature. The mass of an object remains constant and it never changes. However, the volume of an object varies due to change in temperature of the object. Generally, the volume of object increases on heating and decreases on cooling. Since the density of an object is ratio of mass and volume, hence density of object decreases with an increase in its volume due to rise in temperature and vice versa. Suppose mass of an object is m and its volume at normal temperature is V. Due to temperature variation, its volume changes to V1, which results in change in density. Now let's understand it. So the first case is when temperature increases. So when temperature increases, volume also increases. We know that density is equal to mass per unit volume, and if the volume increases, density will decrease because they are inversely proportional. So in the first case, with the increase in temperature, volume increases because of which density will decrease. We can observe that m divided by V1 is less than m divided by V. So we can say that with the increase in temperature, volume increases and density decreases. Next case is when temperature decreases. So if temperature decreases, the volume also decreases, because of which the density will increase, because m divided by V1 will be more than m divided by V. So we can say that as temperature decreases, volume also decreases, and hence density will increase. So as density of a liquid changes with temperature, hence its relative density also changes accordingly. I hope this topic is clear to you. Thank you.